Okay, guys. Lesson 7.1. Finishing up these notes real quick here. We were talking about exponential functions, right? So on the front side yesterday, we looked at the graphs and what the graphs look like. We talked about how to recognize if an equation is exponential growth or exponential decay. And on the back, we were starting to look at word problems. So I think what I'm going to do is let's just jump into the second example here and see if we can remember how we were using this growth and decay equation. So suppose you invest $500 in a savings account that pays 3.5% annual interest. How much will be in the account after 5 years? So even though we're calling it exponential growth and decay, this is interest, right? Okay, you've seen whether it be simple interest, compound interest. This is our variation of compound interest. You've seen this stuff along the years or through the years. So, okay, guys, what can you identify in this problem? Okay, what's A? Our initial value, $500. Okay, what else? Okay. So we have 5 years, which is T, and then 3.5% annual interest is going to help us find our R value. What do we use for R here?
1 plus 3.
Well, just for R, what is our R value?
0.035.
Right, we need 3.5% as a decimal, which means you move your decimal 2 places left, and it is 0.035, correct? So set up your equation. The formula, if you recall from up top yesterday, A of T equals A times 1 plus R to the T value. So we're being asked to find A of 5. So we're trying to find the balance after 5 years. So little a, you guys already said, was 500. In the parentheses, 1 plus. And why are we adding that R value?
Because
It's a growth, not a decay. So we're going to add 0.035 raised to the power of 5. Now, if you haven't tried these on the calculator before, now would be a good time to practice, which is why I asked you to have a calculator at your side. You can enter this whole thing into the calculator as is. If you'd the one thing I would do is I would go ahead and clean it up because 1 plus 0.035 is 1.035 raised to the 5th. But I would just do that whole piece on the calculator as is. Now, if your calculator is not quite fancy enough, which we are going to have some of those, which piece has to be done first? The one that has the power, yes? So if you have to do this in pieces, and I think I failed to mention this yesterday because we were, I think, close on time, you need to start by doing 1.035 to the 5th power, get that value, and then multiply by 500. Now, if you have a calculator that allows it, by all means, type it in. 500 times 1.035 to the 5th. In the end, does your answer match my answer? Okay, and that's good, right? My suggestion here is if it doesn't, the reason I'm doing this now is because you can check and make sure you know how to use your calculator.
This one's all messed up. If you click enter, you'll see that because it adds a minus.
Oh. Let me trade you calculators. I don't know. You know what? What did I do? I don't know if this calculator is doing this. Or maybe it was this calculator. And I reset something to get it fixed. Let me try a reset, but Okay, it's working now, but yeah, there was a setting that had to be fixed, but okay. What kind of answer would you guys give me on this problem? 2 decimal places, right? Because we're talking money. It said invest $500. How much will be in the account after 5 years? This is money. So if you're going to give me money, $593 and 84 cents. Okay, questions on that? You know how to use the calculator you have in hand? Okay. Let's look at our next example. Suppose you invest $1,000 in a savings account that pays 5% interest. You make no additional deposits or withdrawals. How many years will it take for the account to grow to at least $1,500? Thoughts on what we need to do here? Well, okay. Eli talked about making an XY chart. Cyrus?
Can you put 1,500 and plug it into like the first A of the equation?
Okay. And essentially, yes, 1,500 is our first A, so to speak. And let me write that out for a moment, and then I'll come back to, so if we think about the equation, A of t equals little a times 1 plus r to the t, right? You invest 1,000. So what's that at 1,000? That's your little a. 5% interest, what's that? R, and what am I going to use as R? 0.05. If you make no additional deposits. Okay, now, right here, what about this 1,500? Yeah, it is the A of t. Okay, so, I agree, you can set it up like that. We're trying to find, when does this equation equal 1,500? So if I write that out, it's 1,500 equals 1,000 times 1 plus 0.05 raised to the t, which you can clean that up a little bit. 1,000 times 1.05 to the t. And our goal is to know, when does that equal 1,500? Yes?
Honestly, what I did, I kind of gave it like I set up the equation, and then I just put like a random number in for t to see how close I was, and then I judged that by going up or down, and then eventually I would get one number that was below it, and then one number that was like 1 year or whatever that was above it.
Yep. Okay, so, Eli mentioned the idea of an XY chart, and that's essentially what we're doing, right? Carter's talking about he's plugging in random years so he gets in the ballpark, and then he finds 2 years next to each other, right? One below it, one above it. And that's essentially what you have to do here, at least in this stage in the game. Because do we know how to solve an equation where t is in the exponent? And at this stage in the game, we do not. More to come on that. But for today, yeah, basically we're going to set up, I'm going to kind of write it out formally here, but I'm going to kind of set up a t value and A of t. Okay? Now, it was kind of broken up over 2 days, so I don't know if anyone noticed it or not. Is this problem familiar?
Yeah.
Same percentage and initial amount as the top problem? The problem we ended on yesterday? So yesterday it was $1,000, 5%. And we had to find what the account will be after 6 years. What was the account after 6 years? $1,340.10. Is that a good starting point? Yeah, because that already, it gets us past 1, 2, 3, 4, 5. We're already at 6. We're getting closer. And so from here, start trying some numbers, yes? If I go ahead and try 7, then that means we're doing this part right here. 1,000 times 1.05 raised to the 7th. Now I have a number in the 1400s. So 1407, what? 10? $1,407.10. So closer. And if you, at all means, if you want to jump at some point and try something bigger, go for it. Now, if you have this calculator, I can, notice what's at the top row there. I can arrow up to that row, arrow over, change my 7 to an 8, and I don't have to retype the whole thing. So, depending on how your calculator works, you might be able to do something like that. So 1,000 times 1.05 to the 8th is $1,477.46. Try the 9th. So you want me to show you my shortcut again? I just still had this on my calculator screen, and I just arrowed up, and it put my cursor in my problem, and I arrowed over, typed a 9 over the 8, and hit enter. 1551.33. What was my question asking?
How long would it take for the conference to at least?
At least 1,500. What do I want my answer to be? 9 years. Because at 8 years, I wasn't at 1,500 yet. At 9 years, I'm above 1,500, right? And we're not going to go into, 8 years and how many months or anything crazy like that.
So there is a way to actually solve this without having to play guess and check.
Yes. There is a way to solve this equation without guess and check. And we will learn how to solve that type of equation because we would use logs to solve that type of equation. I don't know, maybe 7.5. Trying to remember when we learned how to solve this type of equation. I think 7.5. After we learn about logs a little bit. Do we have a distraction flying around? Okay. Next example. You guys got how we did the last one, yes?
Yeah.
If you wanted to do the next one, you could. Has anyone already tried it? Did you try it?
It's 6 years, I think. Is it not?
8 years.
I have 8 years written down.
Oh,
For real.
dang, messed up.
Okay, so if you want to try it for a little practice.
Oh, I have 8 years in my. I have 8 years in my problem. I put 6 years down for some reason.
Okay.
Like in the exponent.
Okay, so 8 years is the answer for that one if you want to try it. It would be doing the same type thing we just did on the previous problem. It's a guess and check at this point in our math career. Okay? Give us another week and I can give you a method to solve. But for right now, it's guess and check. Okay, one last thing before we end today. Example 4. Writing an exponential function. Okay, so first of all, notice it does say writing an exponential function. So we're going to look at the information given and talk about how to write an equation here. The population of a given species decreases by 20% per year. If the initial population is 150, how many of the species exist after 11 years? So here's what I'm going to say. For the moment, don't read past 150. Okay? Because I want us to practice writing an equation based on the beginning part. The population of a given species decreases by 20% per year. Initial population is 150. we have a formula to use, right? Same formula we've been using all day. A of t equals A times 1 plus R raised to the power of t. What pieces do we know? What do we know, Carter?
It's decreasing by 20%, and it starts at 150. So this exponential.
Okay. Decreases by 20%. And initial population is 150. If the initial population is 150, what does that tell me? That's your little a. Okay. Decreases by 20% per year. What is that?
I think it's subtraction.
Okay. So my R value is going to be 0.2. Since it decreases, when we set up this problem, yes, we will be subtracting. And you could, if you want, you could write R as negative 0.2. Okay. But that is the key. You have to watch. We were doing all these money problems where they're earning interest. And so, of course, it's growth. More of a population type problem. Okay. That's more where you'll see a possible decrease. So if I'm writing an equation, initial value is 150. 1 plus R. What am I writing for 1 plus R? Minus 0.2. Now, you could write this one of two ways. Okay, we can use the A of t and write it as A of t equals 150 times 1 minus 0.2 raised to the power of t. Instead of 1 minus 0.2, how could I rewrite that? Yeah, 150 times 0.8 raised to the power of t. You could also write this in terms of y and x. Okay, and Math Excel might have you do that. I can't remember exactly. But if I write this in terms of y and x, we could also say y equals 150 times 0.8 raised to the power of x. Okay. Now, okay. And I guess what I'm just trying to show you is that, you know, the formula says A of t and t. You can also easily see it as x and y. Okay, so you need to be, you know, flexible, I guess, here. Flexible, willing to go back and forth. Now, finish the problem. Now you can read after the number 150. How many of the species exist after 11 years? So what do? Plug 11 in for t or x, whichever way you're doing this. So if I use the other one, 150 times 0.8 raised to the power of 11. Grab your calculator, make sure you know how to use it. $12.88490189 is my lovely calculator answer. Okay, and this is where we talk about, it doesn't say what it is, but it's a population of a given species, right? So, I'll be honest, sometimes you will see, okay, the population is approximately 12.9. Doesn't really make sense, but I do have a whole number written down here. And so, what is the estimate for this population? Approximately 13. Okay, because it is close to 13. This is an approximation. Okay, if we wanted to, you know, if we were trying to be very specific about how many of this species are allowed to do something or whatever, we don't, you know, some situations, yes, I agree, you can't round up. But this is just an estimate, so we are safe to round up here. Yes?
Is there an actual sign for approximately?
Well, when I do my squiggly equal sign,
I just thought that was an equal sign.
it is officially a squiggly equal sign. It's just sometimes hard for me to, you know. It's hard to make sure it looks squiggly. Okay, your homework due tomorrow is lesson 7.1 in Math Excel. if you don't have 100% on it, you should be working on it right now. If you worked on it and got 100% last night, more power to you. Find something else to do to keep yourself out of trouble, please.